If you are a pilot and you want to fly your plane, is it better for you to think about how fast the wind is, or how fast the wind is and what the direction of the wind is? And is there a difference between the speed of the wind and its velocity? This is what we are going to know when we study the scalar quantities and vector quantities. Let's start.
بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Hello dear students. Today, inshallah, for physics, for IGCSE, we'll talk about scalar quantities and vector quantities. Quantities like length, mass, time, velocity, speed, force, weight, all of these are called quantities. We can classify these quantities into scalar quantities and vector quantities. Scalar quantities and vector quantity. What is the difference between scalar quantity and a vector quantity? The scalar quantity has only a magnitude. What does this mean? This means we need only to know how much it is. For example, here, for time, I want to know the time interval, for example, it equals 10 seconds. خلاص. Now we know the time. It doesn't have a direction. So for the scalar quantity, it has no direction. Again, for scalar quantities, they have only magnitudes and they have no direction. For example, we have here time, length, mass, speed, distance, energy. All of these are examples of scalar quantities. Why? Because they have no direction. All of these quantities have no direction at all. For the vector quantities, they have both magnitude and they have a direction. So to know them, we need to know their magnitudes and their directions. For example, if I affect an object with a force, I need to know what happens to this object. To know what happens to this object, we need to know the direction of this force. We need to know the direction of some quantities to know exactly or to know definitely what these quantities are. For example, here, as we said, we have the force. It is an example here. We have velocity, acceleration, weight, because weight is a type of force, and momentum. Inshallah, we will study momentum. Of course, we'll study weight, velocity, we'll study all of these quantities. And gravitational field strength, and electric field strength. All of these quantities have directions. So all of these quantities are vector quantities. So now the scalar quantities have no directions. The vector quantities have directions. The force, look at this. We have here velocity and we have here speed. Both of them describe how fast the object is, but the speed, it is only how much the speed is. But the velocity, how much the speed is, and what is the direction of that. Scalar quantities have no direction. The vector quantities have directions. Look at this. If I have two masses, a mass equals 5 kilograms, and another mass equals 3 kilograms. Okay, what is the total mass here? The total mass equals 5 plus 3 equals 8 kilograms. Very simple. For the scalars, if we want to get the resultant, the total, we just add them. But what about vectors? How to add vectors? To add vectors means to get the resultant of two vectors. For example, I have here two forces. A force equals 3 Newton. Okay, force A, for example, and force B has or is equal to 4 Newton. What is the total of this? What is the resultant of this? Okay, is it 7? Maybe. We don't know. If someone asks you what is the resultant of a force equal to 3 Newton and another force equals 4 Newton, we just say we don't know. Why? Because we need to know the direction of each force to know how much the resultant is. For example, if I have a box like this, and this box is affected by a force 3 Newton and another force 4 Newton. Look at this. When we represent the vector, we represent the vector with an arrow. Okay, its direction represents the direction of the vector, and its length represents the magnitude. So if I have 4 Newton and 3 Newton, the 4 Newton is a little bit longer than 3 Newton. Okay, this box here is affected by two forces, 3 Newton and 4 Newton, like this. Both of them are acting in the same direction. So the resultant here equals 3 Newton plus 4 Newton equals 7 Newton. Good. What if this box is affected by 3 Newton and 4 Newton to the right? 3 Newton to the left and 4 Newton to the right. What is the resultant here? Exactly. The resultant here equals the subtraction of them. This 4 is to the right, so it is positive. This 3 is to the left, so it is negative. It is 4 Newton plus negative 3 Newton. You can write it simply 4 minus 3 equals 1 Newton. 1 is positive. This means its direction is to the right, like here. Both of them are to the right, so this one is also to the right. Because this is a force, so we need to know its magnitude and its direction. The magnitude, okay, the magnitude and the direction. What if the two forces are perpendicular like this? For example, here, I have here this box is affected by a force 4 Newton to the right and another force 3 Newton upward. How to get the resultant here? We have two ways. We can get it by drawing, simply, very simple, graphically. How? We just make a scale of these two. Okay, this 4 Newton, we can make a scale here for 4 Newton. We can take it as 4 centimeters to the right. For example, this is 4 centimeters to the right. And this 3, look at this. If we want to draw this 3, okay, where do we draw it? We have two ways to draw it. We can draw it here, 3 Newton, 3 centimeters to represent 3 Newton. Okay, look here. To get the resultant, how to get the resultant? By only drawing. If these two vectors start from the same point, look at this, we have to complete the rectangle. For example, here, this is 4, we copy it here, 4 Newton. This is also here, 4 Newton. And the 3 is here, 3 Newton. And the resultant is from the beginning of the origin of them to the end here. This is the resultant. Okay. we measure it. For example, we said this is 4 Newton, this is 3 Newton, this is 3 Newton. We measure the resultant. Okay, so we get it by only measuring. Graphical, we just measure it with the ruler. Okay, now we get the magnitude by measuring its length. How to get the direction? We need also to get the direction. It's a vector. To get the direction, we measure this angle with the horizontal here. We measure the angle with the horizontal, okay, using the protractor. So we measure its length, and we measure the angle using a protractor to get the direction. These are perpendicular, so we complete the rectangle. But we have a simpler way, which is we can draw this 4 Newton like this. Okay, to be easy for us to draw it, we draw the 4 Newton and the 3 Newton after it. So to make it easy for us to get the vector or the resultant vector, we draw the vectors one after another. The beginning of the second one starts at the end of the first one. Okay, after that, we connect the beginning with the end. I think if you go back, you will see the same resultant with the same direction. This is the resultant here. And in the same way, we measure the length using the ruler. Okay, using here the ruler to get the magnitude. And we measure the angle here using the protractor to get the direction. Okay, so this is how to get the resultant graphically or by drawing only and measuring the length and angle. Okay, can we calculate it? If I have a box, the same thing is affected by two forces, one force 4 Newton to the right, and another force 3 Newton upward. Can we get the resultant by calculation? Of course, yes. How? Look here. If I have two perpendicular vectors, like the force and the velocity, and here we'll only talk about how to add vectors. We'll talk only about velocity, the resultant of velocities and force. Only these two, velocities and forces. Look here. I have a force 4 Newton to the right and another force 3 Newton upward. This means they are perpendicular. As we said, we can draw them. This is 4 Newton. And the second one starts at the end of the first one. So this is 3 Newton here. Okay, how to get the resultant? The resultant, again, we draw it from the beginning to the end. This is the resultant. Look here. If we look at this figure, it's a right triangle or right angle triangle. What is the resultant here, or what does the resultant represent here? The resultant here represents the hypotenuse. Yes, it represents here the hypotenuse of the right triangle. And the hypotenuse here, for example, if we say that this is A, this is B, and the resultant of the hypotenuse is C, we can get it by using Pythagoras theorem. What does it say? It says that hypotenuse squared equals each leg or the sum of the squares legs, the squared legs. So from this, we can say that the hypotenuse equals the square root of the sum of the squared lengths. Now we get the magnitude. Okay, this is the magnitude. Okay, what about the direction? How to get the angle? Again, we are here getting by calculations, not by only measuring. How to get it by calculations? We use this Pythagoras theorem to get the magnitude, and we can use the tan. If the angle here is theta, we can get theta equals tan minus 1 because we have here this is the opposite. You know that tan any angle equals opposite over adjacent. So the angle itself equals shift or the inverse tan opposite over adjacent. So the angle here, theta, equals tan minus 1 or inverse tan, the opposite, which is 3 over 4. And the magnitude equals the square root of 4 squared plus 3 squared. From here, you can say that C equals, again, the square root of 4 squared plus 3 squared. Using your calculator, you can find that C equals 5 Newton. And the angle, theta, equals tan minus 1, 3 over 4. It equals approximately 37 degrees. So the resultant here makes a 37 degrees with the horizontal. Again, the angle is measured from the horizontal, or we calculate the angle with the horizontal. The direction of the resultant with the horizontal, not with the vertical. Okay, I hope you understood everything here. It is a very easy lesson, inshallah. Next lesson will be a revision on this topic and the topic of measurements. Thank you. Assalamu alaikum wa rahmatullahi wa barakatuh.